Now there are some popular examples which are finite groups. We have seen that if you have normal addition and normal multiplication, then the small sets which are actually groups are going to contain one or two elements. But if you want to include more than one or two elements, and if you want to make a finite group for various reasons, see, the group concepts of groups can even be applied in various other fields. So one field is, we know that it is going to be applied in cryptography a lot. Okay, but anyway, here the concept is, if you want to make a group in such a way that it contains more than one or two elements, and if you want the operation addition or multiplication to be applied for that, then these operations should be modified a bit, and these are popular examples. So one example is, if you have the numbers from 0 to m minus 1, and this symbol is addition modulo m. So in exam they will give you the verbal description. Here I am directly using these symbols, but in you need not by heart these symbols, they are not standard. In exam they will verbally describe you. So what I mean to say is, if you have set of numbers from 0 to m minus 1 and then addition modulo m is the operator, if you have that, then it is going to be a group. The reason is simple. So why is it a group is, just check this one. Now I'll just take an example. Okay, what is addition modulo m? So first we shall discuss that. So what I mean by addition modulo m is, if you take two numbers a, and if you want to find out addition modulo m b, if you take two numbers a and b, and if you apply the operation addition modulo m, then what it means is, if the result a plus b, this is the result, right? If the result a plus b is less than m, right, then the answer is going to be a plus b. If the result a plus b is greater than m, then the answer is going to be the remainder when you divide a plus b by m. That is the meaning of it. Okay, so I'll better take some examples and explain you. See this, let us say you are talking about 1 and 2 addition modulo 4. Then what is the meaning of it? You take 1 and 2 and you add them, so the result is going to be 3. Now you take the remainder when you divide this number with 4. So what is the remainder in this case? 3 itself, right? Now if you are talking about 3 and 4, let us say addition modulo 4. We know that 3 plus 4 is 7. Now you have to take 7 and divide it with 4, and you take the remainder, whatever you get 3. Therefore 3 is the answer. Got it? Let us say 1 and 6 addition modulo 5. What is the answer? It means that you have to take 1 and 6 and you add them, which means 7, and you divide with 5 and you take the remainder, so which is 2. Got it? Similarly, if you want to take 1 addition modulo 5 and 2, what does it mean? You add 1 and 3 and then you divide with 5 and you take the remainder, right? So if you take the remainder, even if the number is less than 5, you get the same number. That is why if the sum is less than m, I am writing the same number. The reason is remainder is going to be same number. If the sum is greater than m, then you will take the remainder. So in short, you can think of it like this. If you write a addition modulo m b, it means that you should add a and b and then divide it with m, and whatever result you get, you should take it. That is the meaning of it. Okay, so now what I am trying to say is, if you have the numbers from 0 to m minus 1, and if you take addition modulo m, then it is a group. For example, if you take 0, 1, 2, which means 0 to m minus 1. In this case, m minus 1 is 2, which means that m is 3. With this, if you take addition modulo 3, then it is going to form a group. Now if you have any doubt, you can go for the table form and you can see if it is right or wrong. See this? Now 0, 1, 2, 0, 1, 2, and the operation is addition modulo 3. Now check this. 0 and 0 is 0. Therefore I am directly writing. If it is less than 3, you can directly write it. 1. You can directly write it. 1, 2. Now see this. 1 plus 2 is 3, which is not less than 3. Therefore you should take the denominator. That is why I get 0. Now what about this? 2 and 3. Right? 2 and 0 is 2. And what about it? 2 plus 1 is 3. You have to take the remainder when you divide with 3, therefore it is 0. And 2 plus 2 is 4. You have to take the remainder, which is nothing but 1. Now if you observe this, all the values are present in the set 0, 1, 2. Therefore it is closed, which means algebraic structure. Now let's see if associativity is followed here or not. So this is addition, right? So mod 3 or not, it is addition. Therefore associativity will definitely be there, which means it is going to be semi-group. And what about the identity? Since it is addition, identity element is 0. If you want to see it, you can see it here. See this. Now if you take any number and if you add 0 to that, then you are going to get the same number. That is why it is semi-group. Now that is why it is monoid. Identity element is there, that is why monoid. Now what about the inverse? You take either a row or a column and see there should be identity element. See this. Now for 0 is present here, which means for 0 is the identity element here. Got it? And for 1, 0 is present here, which means for 1 the inverse is 2. Got it? And for 2 it is here, which means for 2 the inverse is 3. Therefore for every element inverse is present. That is why it is a group. So you can take any set like that and you can see it, right? So why is 0 important in this set is, without 0 it cannot be a group. The reason is 0 is the identity element, right? And why can't you include m? You can check it. If you try to include m also, which means if you try to include 3 as well, there is no way you are going to get the inverse. That is why inverse of 3. Okay, so that is the reason why we cannot go for more than that. Okay, you can check it. And the next one is multiplication modulo m. Here also it is same, which means if I take two numbers a multiplication modulo m b, it means that you take these two numbers a and b and you multiply them and you find out the like this a and b and you multiply them and then you divide with m and you find the remainder. That is nothing but a multiplication modulo m b. Okay, now sm. So sm is, again I am just using the symbols, but then in the exam they will give you the verbal description, so don't worry about it. You are definitely going to get the verbal description. So what is sm and then multiplication? This is, let's talk about this sm. Sm is set of all numbers which are less than m, which are relatively prime to m. So we have already seen such kind of function in computer networks in cryptography, Euler's function. So S is a kind of it. So what I mean to say is this. For example, okay, understand this. Sm means set of all numbers, all positive integers, set of all positive integers which are less than m and which are relatively prime to m. For example, if you want to find out what is S10, which means set of all integers less than 10 which are relatively prime to 10. What is relatively prime? Two numbers a comma b are said to be relatively prime if GCD of a comma b is 1, then they are called relatively prime, which means there should not be any number which divides both of them other than 1. That is the meaning of it. Simple words, two numbers are called relatively prime if there is no number which is going to divide both of them evenly except 1. Okay, now so what are all the numbers that are less than 10 which are relatively prime to 10? 1 is less than 10 which is relatively prime to 10 because only 1 divides both of them. What about 2? 2 is not relatively prime to 10 because 2 divides 2 as well as 10, that is why they are not relatively prime. And 3, yes, 3 is relatively prime to 10. And 4 is not relatively prime to 10 because 2 divides 4 as well as 10. Therefore GCD is not 1, GCD is 2 there. Okay, and what about 5? 5 is not relatively prime to 10. The reason is 5 divides both 5 and 10, which means GCD of 5 and 10 is not 1. What about 6? Not relatively prime because 2 divides them. What about 7? Yes, relatively prime. What about 8? No, because 2 divides both of them. And what about 9? Yes. So 1, 3, 7, 9 are the numbers which are less than 10 which are relatively prime to 10. Now if you take 1, 3, 7, 10 and if you take multiplication modulo 10, this is going to form a group, and in this group the identity element is going to be 1. You can check it. Got it? So that is how you can find out the small group or small set of elements which are going to be forming a group. For example, one good example is S7. If you have a prime number, then every number less than it will already be relatively prime to that. Therefore, if you take S7, then you are going to get 1, 2, 3, 4, 5, 6. All these numbers are less than 7, which are relatively prime to 7. Therefore, it contains more elements. Got it? This is also a group, so you can check them. They will be groups. So what I mean to say is, these two are popular examples: 0 to m minus 1 and addition modulo m, and then Sm and multiplication modulo m. These are the popular examples of the sets which are finite and which are groups. Okay. And if you want to find the inverses, then you have to work a bit, but then you will get it. Okay. For example, some questions might be like this: what is the inverse of let's say 3? So if you find it 3, you can see this: 3 into 7 is 21. 21 mod 10 is 1. Therefore you are going to get 1. So these two are inverses of each other, 3 and 7. Okay, so you can find it out. So that is how you can find out what are the inverses. For example, if you take 9, what is the inverse of 9? 9 into 9 is 81. Therefore 9 is the inverse of itself. What about 1? 1 is the inverse of itself. So you can find that for every element there will be inverse, right? Here also you can check it. For 1 the inverse is itself, and for 2 the inverse I think is 4. The reason is 2 into 4 is 8, and then 8 mod 7 is 1. Therefore these two are inverses of each other, right? And then for 3 the inverse must be 5. The reason is 5 into 3 is 15, and 15 modulo 7 is 1, right? And similarly for 6, inverse must be itself. The reason is 6 into 6 is 36, and 36 mod 7 is 1. So that is how you can find out the group, right? So simple. The rules are very simple. So there are very few groups, few examples of finite sets, and once you see that in the exam they didn't give you any of these examples, then that might not be a group. I have taken all these standard examples. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have, you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.